Could you please confirm if I'm audible? Please put a yes in the chat. All right, thank you. Good evening once again. Thank you for joining this session. This is our 8th day of the AI Training Plus Internship program. In case you have missed any of the live sessions, the recording of it will be available in the LMS. One thing to announce, to inform you is that we have the Advanced AI Internship Training Plus Internship program enrollment open as well. It will start on the 2nd of July. If you would like to enroll, the details I will put in the chat. Please go to the post page and there you can register for it. Please note that in the option where you fill up the form, please select 1 month extension previously enrolled for basic program. That option you just select when you're registering for yourself for this internship. Okay, so if you're interested, you can extend your current internship program to this advanced AI certificate course plus internship, where you will get it for 2 months and the total hours will be 120 hours. Okay. Now coming on to today's session. Today's session is again going to be taken by Alphy Mathew. She's the research engineer for IPSR Solutions Limited. The session topic is going to be RAG Chatbot Development Part 2. Alphy Mathew is an MCA. She is a research engineer at IPSR Solutions Limited with expertise in artificial intelligence, data science, machine learning, deep learning, data analytics, and software development. She has nearly 2 years of experience teaching and mentoring MSc data analytics students and 2 years in the software industry. Alfie has also served as resource person for Python and AI workshops and is currently engaged in AI product development and research at IPSR. She is a rank holder from MT University 2018 and Marine College Kuttanam 2020. Over to you, Alfie.
Yeah, thank you, Sijin. Thank you for the introduction. Am I audible? Okay, fine. Thank you. Thank you. So before we start, let me share my screen. So can you please confirm that you can see my screen?
Yes, Alfie.
Yeah, thank you, Sijin. Thank you. So good evening and welcome back, everyone. So it's great to have you all with us again as we continue our journey into the RAG-based chatbot development. So yesterday on day 1, we laid the foundation for understanding what RAG is, especially how it works, and most importantly, why we use it. So let's quickly recap. What we have covered in day 1 is that we gone through the basics of RAG, nothing but the retrieval augmented generation. And also we discussed about the workflow of RAG, user asking the question, document is retrieved, then augmentation part, and also context generation and just response creation. Then we discussed why we use RAG, and we also discussed about the drawbacks of current language models. And also we have given an idea what the project goal is for us, like we are going to build a course recommender chatbot for IPSR. One that the chatbot that understands user queries and suggests or recommend the links or the details of the courses that are available at IPSR. So today we will be focusing on the phase 1 of our chatbot development, that is the building the knowledge base. So yesterday we have said that in creating the complete chatbot, we have 2 phases. First phase will be creating the knowledge base, and the second phase will be actual chatbot development. So today we will be focusing on this, how to create the knowledge base, how to create a workflow to implement a knowledge base in Pinecone. So we will first move on to phase 1, building a RAG knowledge base using Pinecone and Innate. So what we are actually going to do here is, we are going to build a smart knowledge base that stores IPSR course information in a way that the chatbot can easily understand and search. So we are going to use, we are going to build an automated drag knowledge base using two main tools, that is Pinecone and N8N. So we use Pinecone, as we said yesterday, as our vector database, especially for storing the document embeddings, and N8N for managing the end-to-end workflow. What this workflow is this workflow in N8N will pulls the data or pulls the document from the course document, and then turns the data into embeddings, and then uploads these embeddings into the Pinecone vector database for the storage. So let's begin by opening the N8N. So what you want to do is you go to the N8N link that we have shared yesterday, then take your account, and we discussed that you will be seeing a start from scratch button. When you click that, you will be getting a interface like this, a canvas like this. Okay, according to your system theme or your dark or light theme, you will be having the color. So I am using dark theme, so it's in dark color. Sometimes it will be in white. Okay, so this is our canvas. Here in this canvas, we will be building the complete workflow. So before this is our canvas, we can just rename our canvas as, just click here, then we can rename as a meaningful name. Suppose update knowledge base. This is the workflow for creating or updating the knowledge base. So we can give a name as update knowledge base. So our canvas file is ready. Now, in this example, we are using Google Drive, our Gmail Google Drive, to store the documents that contain the course details. So we want the document, right? We want the document where all the information regarding the IPSR courses, its description, its links are populated. So where we will store this corresponding document, we will be storing that document in our Google Drive. So we want to first open our Google Drive, then create a folder anywhere in your Google Drive. So let's think of like this. Suppose this is my Google Drive. I am just creating a new folder, and I can give that folder name as, suppose, IPSR underscore. Okay, sorry, knowledge base. IPSR underscore knowledge base. I have just created a folder here. Okay, so inside this folder, I need to upload the document containing the information or containing the details about the courses of IPSR. So I have a CSV file. I'm using a CSV file. As you can see, I have this file in my local system, and this file is like a CSV file, and this file has the title, description, and also the link to the corresponding page. If you go to this link, you can see the course related information about that particular course. So in our document, we are having the list of title of the list of courses available at IPSR, a small description about each courses, and also the link about navigating through corresponding course page. So this is a very small document because we are in the free trial, so we are just using very small or less MB document. So this is a CSV file. This is a snapshot of the file that when we open that. So I am going to upload this file into the current folder. So you go to new, then file upload, then choose it from your machine. Okay, I will be choosing from my machine and it will be uploaded. So I am uploading the file here. So if you have n number of files, you can upload that. If you have these details in the Word document or PDF files, you can also upload that. No issue. So any type of documents can be used as the source documents. So our data source is ready now. So our data source is the Google Drive, and the Google Drive containing a folder IPSR knowledge base, and in that I have uploaded the documents. So we are in the free trial, so we have only uploaded a simple document. So now what we want to do next is we want to create a workflow. So the workflow should read the content from this document, and that gets uploaded into this folder. So our focus will be in this folder, IPSR knowledge base. So any files uploaded into this document, this folder, needed to be taken or read and changed into embeddings and then uploaded to the Pinecone. So we need to create this as a workflow. So also this entire workflow should run automatically. That means the moment someone uploads a new file into this folder, our automation should be triggered. So no one should have to click or any button or manually run the workflow. We need to create an automated workflow that convert the content into embeddings and then store that embeddings into Pinecone. So in simple terms, now we can say that as long as a file lands in this folder, in this Google Drive, the system should wake up, read the file, process the text, convert it into vectors, and then push those vectors into Pinecone. So this workflow is we are going to create next in the N8. So for that, I am just going to my N8 platform. So here it is given that add first step. Okay, you just click on plus, then search for, say, Google Drive. Okay, search for Google Drive, choose that. So here two options are there, triggers on changes to specific file or on changes involving a specific folder. So choose on changes involving a specific folder. So I have chosen that. When we say on changes involving a specific folder, it means that if anything changes in this particular folder, like any new file added or any existing file is updated or even deleted, this workflow will be automatically triggered. So we are adding a trigger node, a Google Drive trigger node, which will trigger this workflow, run this workflow automatically whenever a new new document is uploaded or new document updated or deleted in that particular folder. So this is very useful because it means your automation will respond immediately to the changes in that folder without any manual steps. But what we want next is that we want to connect this Google Drive with our N8. These two are two different softwares, right? So we need to connect them. So for that, we need authentication details or authentication tokens or API keys, etc. We need that. So for that, I already have an account, but for you, I will be creating one more account and will be showing how to create those credentials. So you will not be seeing these two things. You will be only seeing create new credentials because you are going to do it for first time, right? So go for create new credential. What we are going to do is we are going to connect the Google Drive trigger node or our Google Drive with the N8. So we need credentials. So we need to create credential. So click on create credential. When we go for create credential, you can see this is asking something. Give the client ID and client secret. So where we will get this client ID and client secret, that is our next discussion point. So for that, we need Google Cloud GCP account. Okay, so to connect the N8 with the Google Drive, we need to provide the client ID and client secret. So to get those, we need to create a Google Cloud account and create a project on Google Cloud. So for that, I already have an account. So I will be explaining how to create an account. You can do it by yourself. It's very simple. We will be having free version, like free trial version for first 3 months. Okay. So to create the Google Cloud account, go to this link. I will copy this link for you. So before we say, anybody have any experience in using GCP or Google Cloud? I just put yes or no. Yeah, fine, no issues. Just to keep the track of the link, I will put it again. Go to this link And when you go to this link, you can see something like this window will be coming, and you can go for start free. Okay, then when you click on start free, it will be asking you some basic details, your name, your country. Sometimes they will be asking your organization, but you can skip that because you are not a part of any organization. So you can skip that organization part, fill other basic details, and accept the terms and condition. So please note that to create a Google GCP account, like this Google Cloud account, we need to give the payment information. It is mandatory. So we need to give either your credit card or debit card or Google Pay. So I think it will be everybody is having Google Pay. You can give that Google Pay and link Google Pay with this GCP while creating the account. But no worries are there, because this is just for checking your payment method, because it will not pay you automatically. It will for 3 months, for 90 days you will be having a free trial for GCP. So give the Google Pay details, add your payment details, and rupee 2 will be debited from your account, and within 4 or 5 working days it will be credited back. Okay, it was only checking your account is active or it is a genuine account, or etc. So rupee 2 will be debiting from your account, but within 4 or 5 working days it will be credited back. So for 90 days it will be free. After 90 days it will automatically shut down. So you only after upgrading only it will take charges from your Google Pay. So no worries about that. No automatic charges are there after the trial ends. So it is mandatory to give the Google Pay account. Okay, for 3 months is more than enough for you to complete the task and submit. Okay, so create your give them basic details, give your payment details, and create your account for the Google GCP. I mean Google Cloud. So once you have created the account, you need to go to this link, googlecloud.com. Okay, I will give the link. Okay, once you go there, you can see some screen like this. Okay, so there some screen like this. There you need to choose console, this top here, console. So when you click that console, you will be getting a screen like this. Because I am already having the account and many projects are there, so I won't be able to show that. So I have added exact screenshot for you. So after going to this link, you will get a page like this. In the right top, you can go to console. When clicking the console, you will be redirected to Google Cloud console. Okay, so in that console, what we want to do next is we want to create a Google Cloud project. So to create a project, go to the left top. Here you can see a open project picker. So here, click on that, then click on new project. So for free trial, I think you can create up to 23 projects or something. You can try 23 projects in free trial version. So we need to create a project. So suppose we can give the project name as RAG hyphen say chatbot hyphen demo hyphen IPSR. Okay, then just click on create. Now you can see a pop-up is coming by clicking the creating the new project. So in this pop-up, select project, choose select project. So now what happened is that a new project named RAG Chatbot Demo IPSR is created in your Google Cloud and it is get activated. Now you can see our project is active project is RAG Chatbot Demo IPSR. Okay, so our project is now selected and is active. Then what we want to do next is we are doing all this to get this particular client ID and client secret. Okay, so we have created the project. Now what we want to do next is go to this navigation menu, click on API and services. Okay, then choose this library. Okay, then here in this library, search for Google Drive. Okay, we can see Google Drive API. Choose that. The first option, Google Drive API. Click on that. Then click Enable. Now we have enabled the Google Drive API in our RAG Chatbot Demo IPSR GCP project. So it is getting enabled. Okay, after that, go to OAuth consent screen. Here, the left navigation bar, OAuth consent screen. Okay, then choose Get Started. So it is asking for you to create an application name. You can give an app name. So suppose we can give the name as RAG hyphen in 810 hyphen bot IPSR. You can give any names, no issues. Okay, so I have given my app. So we are creating an application in our project. So we have given a name for our application, and we are focusing it for it is asking for what our mail ID. So just to give mail ID, then choose next. Then under audience, we are planning to create this application for external, okay, not internal purpose. That is available to every users, okay, all users. So I can just choose it as external, then choose next. Then they are asking to give a contact information. You can give your mail ID. I am just giving my mail ID. Okay, I have given my mail ID. Then click next, then agree the terms and condition, then go for continue and just create. So our application, that is a web application, is client is created. Now in this screen, go for create OAuth client. So it's asking for your application type. Choose for web application. Okay, let the name be the default. Let it be web client 1 itself. Now here we need to give something called authorized redirect URI. So we need to understand what this means. Authorized redirect URI means. For that, let me discuss that. So don't worry, every single steps that we have followed or every screenshots where all these are there are added in the material. Okay, so you can either go for the recording or you can look this material and you can recreate all these steps. Further, you can refer this. Okay, so here we need to discuss why we are going to use this authorized redirect URI. So here under the authorized redirect URI, we need to add the N18 URL for Google Drive account. So when an N18 URL is added as an authorized redirect URL, during OAuth client creation in GCP, we were doing that OAuth client creation. At that time, it asked the authorized redirect URL. So when we are giving that, it means that Google will redirect the user back to that specific N18 URL after successful login. I repeat, the Google will redirect the user back to that specific N18 URL after successful login, allowing N18 to securely receive the authentication token and complete the flow. Simply, to make it simple, we can just say like that. When you set up OAuth or a Google login in GCP, you have to tell Google where to send the user after login. We are trying to log in to Google Drive or Google GCP from the N18 platform. After logging in, where I want to redirect So that redirecting URL is given here in the redirect URL, authorized redirect URL part. So that's what the authorized redirect URL is. It's the link that Google redirects to after a successful login. So we are saying to Google like, hey Google, after login, send the user back to this particular address of N810, so we can finish the process. Okay. The next question is where we will get this URL. So for getting that URL, you may go to our N810. It's specified here. Look, OAuth redirect URL. The URL is given. So just copy that. Click to copy. When you click it, it will be copied. Copy that URL. Go to your GCP. Under authorized redirect URI, add URI. Paste that URI here. And then click for create. Okay, so a client ID pop-up will be seen. Just ignore this, click on OK. Okay, now we can see the web client and the web client we have created. We can see under this client IDs. Choose this web client one. So in this right part, you can see the client ID and a client secret. So what we want to do is copy this, copy the client ID and paste it in the N810 client ID. And again, in the client secret, copy this client secret, then paste it in N810. Okay, then it will be asking for a sign in. Click for that. Sign in with Google. So choose your mail ID. The mail ID having your GCP account. Okay, then go for allow. Now the connection is successful. Okay, the connection is successful. That is, our N810 is connected with the GCP, our Google account. So you will be getting, if all things go right, you will be getting account connected success message. So just close this. That's only. So you will be seeing this Google Drive account only in your. So just choose that Google Drive account. That will be the latest one. So you can choose this. Okay. Then here we can see poll times, trigger on, folder, watch for something like that. Let me explain each one. Under poll times, we can tell the N810 that how often to check for a new file in a Google Drive. So a corresponding Google Drive folder. That is how often, in every minute or every hour or every day, every week. You can give that. We are just giving it as or keeping by default as every minute. That is the poll times. Then another is the trigger on. Trigger on in the sense when this trigger must be active. That we have already selected that. What changes involving a specific folder. So let it be like that. Next, under the folder list, we need to specify the knowledge base that we have created in the Google Drive. So when you select that, you can see the name of the folder where you have uploaded that IPSR courses.csv file in your drive. So choose that folder here. Okay, the folder we have created just in the beginning. So this folder is from our Google Drive. So choose that folder and under watch for select file created. Okay, file created. It means that whenever a file is created on this folder, this workflow will execute, and in every minute it will be checking for new file in this particular folder. So to test this step, just click on fetch test event. Okay, then when you go to the schema and simply scroll down, you can see, look, our IPSR courses CSV file is listed. Okay, so our configuration steps or all configurations are success. So now go back to the canvas. Here in the canvas, you can see a node is added. A single node is added named Google Drive Trigger Node. Okay, so this is our first node. This node is the trigger node. That is the Google Drive trigger node file created in N8 starts the workflow automatically whenever a new file is added to the selected folder. Which folder? That IPSR knowledge base folder in our Google Drive. So just to keep track, just to go and save your workflow. Okay, just click on save. Okay, save your workflow. So this node is like a smart assistant that watches a specific folder in your Google Drive. And whenever a new file is added, it automatically starts the entire workflow. Okay, no manual effort is needed for that. But to make it even easier to understand, if we say about a analogy or a simple example, we can say like this: Google Drive. Suppose your Google Drive is a mailbox, and outside your home, and let's say you install a smart doorbell that rings every time a letter or a post package is dropped in that mailbox. That is a smart doorbell is just like this Google Drive trigger. Whenever something is added in your corresponding folder, this will get triggered. This will get active. Okay. So now, next what we want to do is, we have added the trigger node, and the next thing we want is, we want to download that file from the drive to N8 so that later we can grab or read the content from the file. So next we need to add is the download node. For that, click for the plus sign. Again, search for Google Drive. This time choose download file. This time to create or credential, under credential you do not want to create a new credential, you can use the same credential, that is we used this 3, right? You can use that same credential, choose that credential, and under resource keep it as file itself because it's a file, and the operation we want is the download, so keep operation as download. And now for here under file, choose this list from as ID, change it as ID by ID, and we want to give the ID of the corresponding file needed to be downloaded. For that, to get the ID in the left panel, here in the left panel, scroll down, just scroll down. When you scroll down, you can see, look, you can see the course name here. Okay, then grab the ID just before the course file name. You will be seeing many IDs in between, but make sure that you are grabbing or you are choosing the ID that is just below the IPSR courses.csv, your file name. Okay, for choosing that, just click the ID, drag the ID, place it in this box. Okay, now the ID is added. Okay, so that file is added. To check whether this step is executed correctly, we can just execute step. Yes, it's working fine because you are ready to download that. We can download that. So it means that this node can download that file. It is working fine. If it is not working fine, we will get some error messages here. But here its output is no errors. It's just success. So next go back to the canvas. Now we can see two nodes are there in our canvas. One Google Drive trigger node and other Google Drive download file node. Okay, so finally we have added the trigger, we have downloaded the file from the Google Drive. Now we need to grab the content from the file and insert that into the vector store, Pinecone vector store. So for that we need Pinecone account. Okay, so let us discuss something about Pinecone. So all those steps with the screenshots are added here for your reference. Okay, so to get access in Pinecone, what you want to do is go for this Pinecone link and Okay. I need to make it reduce the spin. Okay, fine. I will be reducing. Okay. Uh, so from now we need to take this account in Pinecone. For in Pinecone, what we want to do is you need to create an account. For that, you go to this link. In that link, what it will be asking you the mail ID. So you give the mail ID, and they will be giving you an OTP like that. Will be sent to your email ID, and you can take an account in Pinecone. Okay. So after taking the account in Pinecone, what we want to do is that we need to create an index in the Pinecone. Okay. So Pinecone also offers the free trial versions. So we will be using the free trial, and it has some limitations in the storage or the usages of how many indexes can be created like that. So for our task creation, it will be more than enough. So we will be using the Pinecone free version. So you take the account in Pinecone, and then what we want to do is that before we start doing, let us discuss what this Pinecone exactly means, or what are the uh, what what are the peculiarities or features of this Pinecone. So Pinecone is what we call a vector database. It's built specifically for storing and searching the embeddings, which are basically, yesterday we have said, which are basically what are embeddings we have discussed. These are the numbers that containing the exact meaning of the text or images. Okay, this makes Pinecone super useful for AI applications like any chatbots or any recommendation systems or any smart search engines. So why should we use Pinecone instead of a regular database? Because Pinecone has many features. First feature is that it is very fast. That is, Pinecone can quickly find most relevant information from a massive amount of data by comparing the embeddings. Also, we can scale it very well. Scale it very well in the sense, if we want to add more documents or if we want to increase the size of the index that you have created, you can do it very easily. Also, it is designed for RAG, like for RAG based systems or RAG based technologies. If they are very perfectly useful, then it is fully managed, because we do not want to worry about any setup or any maintenance or any hosting, any server related issues or server related management for this keeping this Pinecone working. So it is fully managed. We only need to create the account in this Pinecone. So to have a quick look on what is vector database, we have already explained this yesterday, but just to rewind, a vector database is special kind of database that's meant for searching by meaning. So in regular databases, you can search for exact matches like name starting from XYZ, or female candidates, like that, because we will be searching for the exact matches in the regular database. So let me ask you, like, anybody have any info, any knowledge in databases, any regular databases? In which database you are familiar? Just put it on chat. If no, just give it us no. Yeah, MongoDB, MySQL. Yeah, okay. So the regular databases are basically to find or search the exact matches. But here in this vector databases are actually we can find similar meanings. Okay, so find me something similar in meaning to the sentence. We are asking like that. If you are giving a sentence, we are asking the vector database to find us something familiar in meaning to this particular sentence. So this is super powerful for AI because we don't just match the text, we are understanding the text. And that's exactly why we use Pinecone in RAG chatbot for the semantic search. Semantic search means meaning search based on the meaning. Okay, so for RAG, it is basically we need a search based on the meaning. So we are using this Pinecone for as our vector database. Okay, so just to understand what actually happens in the embedding model, what happens exactly in the vector embeddings? What are these vector embeddings? We have added one slide here. So when we look at this diagram, we can understand one of the most important steps in building a smart chatbot is creating the vector embeddings. So all the course information, the course title, the course description, the links, everything must be converted to vector embeddings. We have discussed it yesterday. So when we pass our documents or data like text, PDF or images, etc. into an embedding model, it creates the vector embeddings. Then what are these vector embeddings? We just look on that. They are nothing but number-based representation of each piece of data or document. Why do we convert data into numbers? Why we do convert data into numbers? We have discussed it yesterday because AI doesn't understand text or images the way humans do. It needs a numeric format to work with. So the embedding model converts each entry like a paragraph or a sentence into long list of numbers. Suppose the document is there, document is splitted into different chunks, and each chunk will be going to an embedding model, and this embedding model will convert it into a long list of numbers. So this list of numbers is known as the vectors, and each number in the vector helps capture the meaning of that content. So some terms need to be introduced here, that is the vector size or the vector dimensions. So what are the vector size or vector dimension is that the number of elements in each list. This vector dimension is 5 because it has 1, 2, 3, 4, 5 elements in a row. So we can say that the vector dimension here is 5. So we will say vector dimension or vector size. Okay, so the vector dimension or the vector size depends upon the model that we are using. There are different embedding models available. BERT models are there, sentence transformers are there, Google Gemini embedding models are there, OpenAI embedding models are there. Different models have different vector size or vector dimensions. So in the image here, each row represents this vector, basically a numeric representation of your data, like a sentence or a paragraph. So the number of the values in a row is what we call the length of the vector or the embedding dimension. So in this example, we discussed it's 5. Okay, but in real models like OpenAI, Google Gemini, or any other real models, it will be 384, 768, or even more. Okay, that means each embedding model give you vectors of different length. For example, if one model is giving you a vector of 384, other will be giving 788 or even 1000 plus. Okay, it may go above 1000. So the dimension of the vector or the length of the number list depends upon the embedding model that we have used. Important point is, the longer the vector, the more detail or more meaning it can capture. I repeat, the longer the vector, longer the vector means longer the dimension, longer the length, the more detailed the meaning it can capture. But also more storage and more computation power needed. So once we have this vector embeddings, we can store these vector embeddings into a vector database. Okay, so here we are going to use Pinecone as the vector database. So we have added these two slides in to understand about what is Pinecone and kept a short description and short intro about what is this vector embeddings, or what we are exactly meaning of this vector embeddings. Okay, so next we can go hands-on again. So after creating the Pinecone account, you will be landed in a page like this. Okay, you will be getting a dashboard like this. So here, what we want to do is we want to create an index. Okay, index in a Pinecone. So think of an index like what? It's a cabinet, or a cabinet where all your course information is going to be stored. Okay, it will be the storage area where you will be going to store your course information. Okay, so we can create an index here. So click on create index. We can give a name for this index, suppose N810 hyphen demo hyphen IPSR. I have given a name for my index. Okay, you can give any name. So in this index, they are suggesting different embedding models. Look, there are text embedding, OpenAI embedding is there, different versions are there, Pinecone embedding is there, Microsoft embedding is there, Llama. Different embeddings are there, but all these are paid. So we cannot use that. We are in the free trial, right? If we go for a plan, choose a plan, and if we take a paid version, you can use and try this, but now we are using free trial, so we can go for custom settings. Okay, custom settings. Here I have checked this custom settings. In this custom settings, choose vector type as dense. Okay, why we are choosing this vector type as dense? Because we are going to use embeddings which are basically long list of numbers that capture the meaning of each course description. Okay, so we are going to use embeddings which are basically long list of numbers that capture the meaning of course description. That is course description, course title, and also the course link. So these lists are packed with values. So we use the term dense because it is like all the list elements are having values. So it is a dense value. So each course details get converted into list of meaningful numbers, and dense means that those lists are full. That is no entries in the list is empty or sparse. Sparse in the sense many of the entries are empty, that is sparse. So we are saying that it is not sparse, it is not empty, it is dense. All the list entries have number in it. Okay, that is this vector type dense means. Next, under here metric choose cosine. Okay, cosine means this tells Pinecone that how to measure the similarity between the two pieces of data. So when the user is asking a query, we will be taking that query, converting it into the embedding, and also that embedding is searched in this particular vector database, right? We have yesterday seen the workflow. So how the similarity will be checked? Any measures there to the measure is the we need to check the similarity. That measure is the cosine similarity, that is cosine measure. So this tells the Pinecone how to measure similarity between two pieces of data. So the cosine similarity measures how close in meaning two documents or two questions are. Actually, it will be the vectors. It is finding the similarity between the two vectors. So if your chatbot asks, what courses cover data science? Cosine helps it find course description that are most similar to your query. Okay, so the similarity will be calculated in between these vector embeddings, these list of numbers. Okay, so we have given the vector type and also the metric. Under dimension, so we can give it as 768. Why? Because this dimension is the size of the embedding, that we have discussed the length of the vector or the dimension of the vector. No, that dimension is this one. So we are saying that this is the size of the each embedding, that is the number of values in the list, that is each piece of list, the number of entries in a row. So if we are using Google or BERT, we are going to use Google embedding. Okay, when we use the Google embedding, the dimension of Google embedding is 768. So I have given it as 768. So you can think of like this. We are telling Pinecone that, hey Pinecone, I am giving you a meaningful data made up of 768 dimension. That is 768 values per entry, and use the cosine measure to figure out how similar two pieces of the information are. Why the 768? Because we are going to use Google Gemini embedding model later. So the Google Gemini embedding model have the vector dimension as 768. If we pass a piece of text into Google Gemini embedding model, the vector that will be created will be having the dimension 768. So we have given it as 768. Okay, so keep other settings as default. Let it be all default. Okay, then click for here, create index. Okay, so now we have created our index. That is, you have just set up the brain space. We have created a space in Pinecone to upload our embeddings. So we haven't created any embeddings, but we have only created the space. Now the next step is we need to connect this Pinecone with our innate. Okay, so for that we need APIs. Okay, we need API key. For that, go to this API key here at the left side navigation menu. Go to API key, choose for create API. It will be asking for a name. You can give it as Nathan -board -demo -IPSR. Okay, then give any random name and then just create for go for create key. Okay, so now you will be prompted with an API key. Do not close this because this key is only available once. So if you want to use that, just immediately copy that key. If you close this, you will not be getting this key. You need to create another API key again. So just copy that. Then come to your innate. Okay, come to your innate. So here we need to add the Pinecone, right? So for that, go for this plus sign, search for Pinecone. Look, Pinecone vector store, choose that. Here, choose retrieve documents for add documents to vector store, not retrieve, add. We are going to add documents, right? So choose for add documents to vector store. So click that. Okay, so it is asking for a credential. So when you do that, you will not be having this. You will be only having this new credential. Okay, so choose that, create new credential, paste that API key here. So I have just copied that API key. You just paste that API key here. Then choose save. So connection tested successfully. So now we have connected innate with our Pinecone account. Okay, just close this. Now we need to add something here. So it is asking some details. So we have our credential added. Now it is asking for an operation mode. Okay, so operation mode, keep it as insert documents because this tells the node that we want to upload our data to the vector store. So the operation mode will be insert documents. So let it be the same. Now under here we can say see a Pinecone index. Okay, so choose the index. the index that we have created. Okay, this one we were creating today. We for the demo we have created this N18 demo IPSR, right? So choose for that. Okay, choose the index name. Okay, that you have created in the pinecone. Then under embedding batch size, you can give any number. What this batch size means, this simply controls how many pieces of data are sent at once to the pinecone, from N18 to pinecone. How many pieces of data are sent at once? Let it be 200 itself. If you want, this is only a small data we are using, or document we are using, so let it be 200 itself. So it is the embedding batch size means it simply controls how many pieces of data are sent at once. So 200 is safe and efficient file by default, so let it be. Then what we want to do next is we want to create under option, choose add option, choose pinecone namespace, and give a name to your namespace. Suppose I am giving it as IPSR hyphen, any name you can give. IPSR hyphen courses hyphen namespace. Okay, IPSR hyphen courses hyphen namespace. So this, what is this namespace? It means that this is like a folder inside your index. Okay, you have created an index in the pinecone and we have named that index as N18 demo IPSR. So we are asking here in N18 to the pinecone that inside the N18 demo IPSR index, create a folder or create a namespace named IPSR courses namespace. Okay, so once this workflow is run, or when it is successful, what happens is like in the pinecone inside the N18 demo IPSR index, you will be having a IPSR courses namespace folder, and inside that all the embeddings will be stored. So simply we can say that an index is like a big container where all your vector data is stored. Okay, index is like a big container where all your vector data is stored, and it's where the pinecone keeps your chatbot's memory. Okay, a namespace is like a folder inside the index, so it can organize it. For each document we can give different namespaces, etc. for advanced chatbots. So for here we are only creating one namespace. So after doing this, just go back to canvas. Okay, in the canvas we can see that pinecone vector store is added, but there is an error. Okay, so why? Because this error is that the pinecone vector store is expecting something. Some two things they are expecting. That is, first one, it is expecting an embedding model, and it's also expecting a document loader. Okay, an embedding model and a document model. Why? We need to discuss that. So the first one is the embedding model. So I think you get an idea what is an embedding model. So this is a translator that takes the human text or the sentences or the paragraph from the document and turns them into numbers. We need a model to do that. So that model must be added in here in the embeddings. Okay, as we discussed earlier, these numbers are not just numbers. These are the vectors that actually represent the meaning of the text. The second thing that the pinecone vector store not expecting is a document loader. Now this is the part, that is the document loader is the part that pulls in your actual files. We have only downloaded the file. We didn't even read the content from the file. Okay, so to read the content from the file, we need a document loader. So to summarize, we can say that the loader, the document loader, brings the raw content, the content from the file downloaded, and the embedding model or the embedding function turns that into the vector embeddings, and those vector embeddings is going to be stored into pinecone vector store. Okay, so first we are going to add a embedding model. For that, under this embedding, click this plus sign. Okay, there you can see different embedding models are available. The thing is that many are paid versions. So if we are already using that GCP, right? We have created a free trial in GCP. So we can use the GCP like Google's embedding model. Okay, so we can go for embeddings Google Gemini. This one. Okay, embeddings Google Gemini. Click on that. Okay, so again it is asking for credentials. So here we need not the client ID or the client secret. We need Google Gemini API key. Okay, so for that we need to create or we need to add the Google Gemini API in our Google Cloud project. So go for the Google GCP account, your console. Again, click in the navigation bar. Go for API and services. Okay, in the navigation, go for API and services. Then again, click for library. The same step we have done before. Okay, go for library. This time, search for Gemini. Okay, Gemini API. Search for that. The first one. Click on that. Okay, then click on enable. Okay, in the upcoming window, go to the left side, this credentials here. Click for credentials. Okay, go for create credentials. Choose API key. Yeah, we got a API key. Just copy that API key. Okay, just copy that API key. Then what we want to do is come to our canvas, click under credential, create new credential, give that API key here. Okay, then choose save. Our connection is tested successfully. So we have connected our N8N with the Google Gemini API. Okay, just close that. Okay, now we can see that different models, different embedding models of Gemini versions are available here. Okay, you can choose any. For now, we can choose text embedding 004. Okay, we can choose this one. I am choosing that one. Then go back to the canvas. Look, an embedding model is added. Okay. So now what the next we need to add is the document loader. Okay, the document loader is the one responsible to read the raw text or raw content from this particular file that we have downloaded using this Google Drive download file node. So to add this document loader, again click on this particular plus sign. You can choose this default data loader. Okay, default data loader. Choose that. So under that, we are sending or we are uploading the data from N8N to Pinecone, and it will be better that the type of data must be in binary format rather than JSON, because it will be more secure and more fast. So we have choose the type of data as binary. That is, binary data can be handled easily in this workflows. More speed and more efficient, it's binary type. So we have chosen the binary. Now let the mode be by default, it will by default setting. Then go for this text splitting. Now under this text splitting, you can either choose simple or you can choose custom. So if you are using simple, it will be giving you 1000 characters with 200 character overlap. So to understand that, we need to discuss what is this overlap, what is this character means. Okay, we will be discussing that. For now, we are using only a very small document, and we do not we only need some character splits or overlap, so we can use custom. Okay, I will be explaining what is this overlap and what will be these characters. So we can choose for custom. Okay, I am choosing for custom. Then just go back to the canvas. You can see that a default data loader is added. Okay, so this default data loader is expecting some text splitter. Okay, this default data loader is expecting some text splitter. We can add this text splitter. So for that, click for this plus sign. We can add this recursive character text splitter. Add on that. So here it comes. I said no. What is this overlap and the character size? That is here. You give this as 500. Okay. For small documents, 500 is enough, and chunk overlap as 20. What this means is that, so when we set the chunk size to 500 characters, we are telling the system to break the text into pieces of around 500 characters each. So I repeat, when we set the chunk size to 500 characters, we are telling the system to break the text pieces into 500 characters each, which is usually about a size of a paragraph. Okay, so for larger documents, the documents having so much data, we can use the chunk size as 1000 or about 1000. So our data set or the data is a small size, so we can 500 is enough. For larger documents, you need to keep it as thousands or 2000 above. Okay, so then what is this overlap means? Overlap means we have given it as 20. The overlap of 20 character means that each new chunk will repeat the last 20 characters from the previous chunk. So when we are creating the chunks from, or we are splitting the text into different chunks, so each new chunk will be having the previous chunk's latest 20 characters repeated. Okay, so this small overlap helps the language model keep the flow of the meaning. Okay, so it doesn't forget what just said previous part. Okay, so I repeat again, chunk size means that it is the 500 characters. It means that we are telling the system to break the text into pieces of around 500 characters each. And when we are going with 20 overlap, it means that each new chunk will repeat the last 20 characters from the previous chunk. Why we are doing is like we need a flow of the meaning. So we are just adding the 20 character overlap. Okay, so we have added the recursive characters text splitter. Then go back to canvas. Now the splitter is ready. Okay, so this is what we done here in the custom part. Custom part, if you were using that simple rather than the custom, no, if you are using this without this custom, if you are using this simple, you do not want to add this text splitter. We gone for custom because our data is very small and custom is handy. We can give the number of chunks and we can give the overlap count, etc. So it will be better you go for custom. Okay, now our workflow is ready. Okay, this is our complete workflow. So we can just execute this workflow. Yeah, its workflow executed successfully. Now you can see that here 141 items are there. Okay, 41 items are there in the Pinecone store. So before we discuss what is this 41 items, let us check the Pinecone index. Does this content is uploaded? Let's go for Pinecone. Go to this database section. Okay, database. This is the index that we have created today, right? So just click on that. Look, you can see that under IPSR courses namespace. This namespace we have given in N8. You can see that 41 documents are uploaded. Look, these all are the content from our IPSR.csv file. We cannot see the vector embeddings because it is hidden from us, because we know that the vector embedding size is dimension is 768 list of like in a row 768 entries will be there and numerical values. So this is hidden from the user interface, but it is also, the embedding is also stored in this Pinecone vector database. So here the knowledge base is ready. Our knowledge base is ready. So we need to understand why this 41 items. What is this 41 items? So for that, 41 documents were added to Pinecone. That is this meaning. 41 items means 41 documents is added to Pinecone. First of all, these aren't 41 separate files. Okay, it is only said as documents, but it is not separate files. What actually happened is we took the file from our Google Drive, that is our CSV file. Those files were split into smaller chunks, meaningful chunks, on the basis of the chunk size and the overlap we have given in the text character splitter. And then each of those chunks was converted to vector, that is the numerical vectors, and finally those 41 vectors are stored in the Pinecone. Okay, so this 41 documents means that Pinecone is holding 41 separate pieces of information that can search through based on their meaning. So why this 41? Because it will be based on the this chunk size and the overlap that you are using. If you are using for 1000 chunk size, then it will be smaller. 49 will be 41. It will be lesser. So how we are going to split? That much of documents will be coming here. So now our entire workflow that for the phase 1 is ready. Okay, so inside the Pinecone index, you have seen the namespace. This is the name with the 41 documents. You have seen this one. Okay, so before we conclude, we can just go one by one. Again, what exactly happens with this workflow from end to end? Okay, so I know that many configuration steps, many clicks, many drags, and many connections are done in between the sessions. So it will be hard for you to remember it. I know that. But what you can do is either you can look for the material uploaded in the LMS. Each step is clearly mentioned step by step. What you want to do, what is each next, where you want to click, everything is clearly mentioned in this PPDF learning material. Or you can go through the recordings itself and you can recreate. Okay, these are only drag and drop or so many clicks. This is a workflow, right? So you can only first refer something and do it or recreate it again. So before we wind up, let's look into the overview of what knowledge updation workflow. What exactly happens? How the execution flow goes. Okay. So let me give it in slideshow. So when we walk through how our automation is structured step by step using the N8 and workflow nodes, first the workflow start at the Google Drive trigger file creator node. It is our first node. This is where everything begins. Okay, we use the Google Drive node trigger in the trigger mode with the event set to file creator. That means whenever a new file is uploaded to a specific folder, our folder is IPSR knowledge base. In specific folder, this node detects that, and it will say the workflow that hey, a new file is arrived. Go. Just start the workflow. Okay, this eliminates the manual work and the workflow starts automatically and hands-free. Okay, so and this is perfect for real-time updates when the chatbot's knowledge base. So whenever a new file is added to that folder, this trigger will be done automatically. So that is the first node. Then comes to the Google Drive download node. Now that our trigger has spotted, suppose our trigger has spotted a new file. What happens is that the next step is to download that file using Google Drive download node that you have seen in the screen. So this is the actual file that was just uploaded. It can be either PDF doc or any document that contains the course content or the content we need to store. So why do we need this step is that because in order to read, split and convert the content into embeddings, we first need to pull the file from the drive. So this Google Drive download file is pulling the file from the drive. So in simple terms, the node is saying, let's grab the file and get it ready for processing. So this step ensures our workflow has direct access to the latest uploaded material ready to be turned into AI-friendly data. In the next step, the control goes to default data loader. Okay, now what happens is here, we have downloaded the file. This default data loader opens the file, whether it is PDF or any type of file. It opens the file, it reads all the content inside the file. That this means it is pulling out all the text data like a person is reading a document from start to end. Okay, why is this important is that because before we convert anything to embeddings, we need to extract it to text. So the raw text is what we will split and embed in the next step. So what this default data loader do is that it is like this. Here I have opened the document and here are everything it says. So default data loader is responsible for reading the content from the document. Then the control goes to recursive character text splitter. Now that we have all the raw data or raw text read from the document, it's time to break it down into chunks. So large documents can be hard for AI models to process at once. Okay, so we break the text into smaller, meaningful chunks. So that is kind of slicing into paragraphs or sentences like that. So we have add how to slice. We have added the chunk size and also the overlap there. And this recursive character text splitter takes the full text and split it into smaller chunks. So it is saying like, let's break the sentences or break the data into paragraphs so that we can understand each part correctly. Okay. Now what happens is that this splitted chunks are passed through the Gemini, Google Gemini embedding model. So each small chunk from the previous step is passed to the Google Gemini, and the Gemini processes the text and turns it into embeddings, just as the vectors, meaningful vectors, that is list of numbers that represent the text semantically. Semantically means meaningfully, representing the meaning. So we are translating the plain text into the language that the AI models can understand. That is the numbers within the meaning. Now, after converting that into numbers or the vectors, we are saving that vectors into Pinecone vector data store. So this Pinecone is now the memory of your chatbot, your knowledge base of your chatbot. When someone asks a question, the chatbot doesn't guess. It goes to the Pinecone, searches for the most relevant chunks and give the accurate response. So in short, all your course content is now stored as meaningful numbers, searchable, smart, and ready to power your RAG chatbot. So where it is stored in the vector database. Okay, that we have used the Pinecone vector database. This is the entire workflow. We have the trigger node. The trigger node will activate the workflow. It will, when a file change or a new file created event is done in the our Google Drive folder, the workflow starts. It will download the file. After downloading the file, the default loader will read the content of the file. After reading the content of the file, these are split into smaller chunks, and each chunk is converted into Google embeddings using the Google Gemini, and each embedding is stored into Pinecone vector store. And we have 41 items stored in the Pinecone vector store as the data. our database or our knowledge base for our chatbot. So this is the complete steps we want to do in the phase 1. So in phase 1, you have built a smart pipeline that automatically picks up the file from the Google Drive, reads them, and turn them into embeddings using the Google Gemini. So we have built the knowledge base, a place where your data is stored in a way that's easy for AI to understand. So now it's the time to build our chatbot. But chatbot is it's for our day 3, not day 2. It's day 3 goal. We will be creating the AI agent chatbot for day 3 tomorrow. So what you want to do is that you need to recreate all the steps we have learned in this today's session, because we have done so many configurations. We have taken some API keys from GCP and given it in N8. Something from N8 is taken and pasted in GCP. So many steps we have discussed. Okay, so you need to go through the materials or the recordings in the LMS and recreate the step and do the same IPSR chatbot from your site. Okay, build the RAG knowledge base of your own. After that, in LMS, you will be having a task. Okay, in the task file, there will be having 2 tasks. First task will be recreate the same knowledge base creation that we have seen in this session using the IPSR courses CSV file. That file will be shared with you through the LMS. So you can recreate the same thing using offering the LMS material and also the recordings video. And the second task that is in that you will be having a 2 tasks. The second task will be another document will be provided to you. Exactly for a union budget database. Okay, file regarding the union budget. You can go through the steps what it is asked to do. You can create a chatbot for asking or getting queries regarding the union budget of 2025 union budget. So task will be uploaded in the LMS. But take your time to understand each step thoroughly. But don't rush through it. What I want to say, because this is where the learning happens. So please know that you are not required to complete the task before the next session. Okay, you are not required to complete the task before the next session, but please make sure that it is finished and uploaded to the LMS before the end of your internship. Okay, so this is an essential part of our learning journey. So there is a chance for you to showcase your practical skills. So, and that's all for today. We have successfully built our phase 1 workflow to create our knowledge base. So keep practicing what you have learned. Stay updated. Okay, so I just reminding you, we are in the free trial of N8. It is only a 14-day free trial. So if you are planning to have to try out this, you need to complete both tasks. You will be having task today and you will be having task tomorrow. So both the task set must be completed within the 14-day period. Otherwise, you will be losing the access to free trial of N8. So be vigilant like that and act accordingly. Okay. So stay updated. Thank you everyone and happy learning.
Thank you, Alfie. Thank you for that wonderful session. If you have any questions, you can put that to Alfie now. Please note that we will continue the session tomorrow. The third part of it will be there at 7 p.m. tomorrow. And also you have the option to extend your AI internship program to the advanced AI internship. The link of which I've already put in the chat. I'll put that again. If you would like to extend your this AI internship program to the advanced AI internship program, you can do that by going to our post page and registering it. All right. I think we will end up. We'll stop for today. We'll see you all tomorrow at 7 p.m. Thank you, everybody, and have a pleasant day.